Ah. Good evening, everyone. Welcome to our TA office hour. There's some problem with my cameras. I won't be able to turn it on until I restart my computer, it seems. So I guess we can just continue like this. How's everyone been doing?
Good.
Good. Yeah.
I'm sick, so I'm gonna have the camera off too.
Glad to hear.
Hello. Yes.
Hi, it's you.
Hello, Jerry.
I have finished grading most of the exams submitted. So you will get the results soon.
Every time you release the question, I was either driving or doing something. So nervous.
Well, no problem. I mean, it's nothing astonishing. So most students did well, and I was glad to find that.
Hopefully I'm included in that.
I think so. And don't worry if you got some points lost, but I was trying to find whatever steps are made correct, so partial credits are given.
Oh, that's nice.
Well, has some of you started working on homework 7? It's a continuation of what we learned last time, so we would use some of the tables and decision tree to calculate probabilities again.
Yeah, I'm hoping I did everything correct. I worked through all the problems. I felt like number 2 was hopefully more straightforward. Problem number 2, and then problem number 1, I just maybe want to see if I have the thinking correct.
Oh, okay, excellent. Glad to hear that you already worked through both of the questions. So which part would you need more help?
Well, maybe I'll ask, oh gosh. I don't want to take over everything. Maybe we'll start with 1A, and it might make more sense as we walk through it.
Okay, sure.
So
would you like to provide some of your thinking already?
yeah, so for 1A, because it's the extreme optimist, you look at all of the best scenarios under declining, stable, and growing, and then you would choose the best one out of all 3.
Yep, that's a good approach.
And so and then for the extreme pessimist, I looked at the declining, the stable, and the growing, and I looked at all the worst ones. And I chose, oh, did I choose the wrong one? And I think I chose the best one out of the worst options. Did I do that right?
I did the same.
Yes.
Maximum, like best of all the worst.
Mhm.
Worst.
Yeah, so for B, it also sounds a very good approach.
Yes. I'm like double checking I did everything. It like you go back and you look at it and it's very, at least where I'm at, I'm like easy to get confused. So and then for part C, for minimizing, I'm trying to think, oh yes. So for minimizing the maximum regret, we look at what is the worst possible outcome for the declining, the stable, and the growing. And then you choose, oh gosh, I'd have to go back and look. I think I did all the work right. And now I'm like,
Oh, yeah, from your description, it sounds good.
yeah, I can't remember. Because I did the, yeah, now I'm wondering if I chose the right one. Because
Oh,
I'm
I see.
talking back through with you.
Were
I'm
there
looking-
any doubts when you made such decisions?
Oh, okay. I'm like, remember, because it's like, I'm trying to remember. It's, you choose, you look at the maximum regret for each choice, and then you minimize that. And so,
Yeah.
so you minimize your maximum regret. And so it'd be 170, is that 100? 190, I think. Yeah, 180 is my would be the least of the three, and so would be a stable population.
Okay. Yeah, you may not got the you may have not got the
Well, I could share my secret.
regret correct, but yeah, it's a the approach to address it is good. When you said that we need to find the largest regret from each alternative, and then among the largest, we find the minimum. So that's
Yeah.
why it's called to minimize the maximum regret.
So I found it's the single family home under stable population has the minimum maximum regret. And so I guess for some of these, I was a little confused about, am I giving you the number or am I giving you the title of like the column or the title of like the row? I'm like, I kind of gave you everything.
Yeah, that'll be the best. So I understood which
Okay.
approach was taken. If you supply both the numbers you based on which the decision was made, and also the final decision.
Okay. If anybody has other questions, I'm just kind of walking through.
I thought I get it right, but now after you said it, I think I did correct at the beginning, like just try to calculate these regret, like how much the thing costs, like opportunity cost, something like that. So, but ends up when I'm picking it, I think I picked wrong one. No, so I picked so when you minus everything and then you get the numbers, you pick every single row, you pick the larger maximum one, and then you pick the minimum out of the max. Is that correct?
Yeah, that's how we do the regret selection. So the regret is the amount of potential money that's lost. Then we try to minimize the possible maximum lost, possible maximum loss.
Katie, I totally feel you. I suddenly, I was so clear when I do it, and now I.
Yeah. You go back and you say it out loud and you're like, wait, okay, I have to get there again.
Do you mind share a screen? Like we can walk through really quick. I think we need to repeat over and over to.
Yeah, if you give me, if Jerry gives me share rights.
Sure, I can do that. I just enabled it.
Oh, there it goes. Okay. Okay, you guys can see this?
Yes.
Yes.
Okay, so for homework C or 1C, I did, right, because if you're a declining population, 220 is the best option. So there's no cost. But 85 minus 220 is 135. So there's like a 135 cost.
Oh, I see. That's how
And
you got these regret indicator. I see.
Yeah, and then 250 would be the regret for condominiums. Sorry, I'm sick. And then 95 for 175, 0, 85. And so I found that under the declining, the stable, and the growing population, 95 was the least amount of regret. Sorry, I had to mute if I can. Here we go.
I had the same answer, but
How did you get 95 again? I was trying to.
It's 95 minus 175.
Oh, 95 minus 175.
Wait, I think it's, let me try it again. Let me try 175 minus 80 equals 95.
Oh, right. Okay.
I picked the 250.
Oh,
And I picked the 140 for apartments.
Because I thought it was you find the maximum regret under each population,
Mm-hmm.
and then you find the least amount of regret after you find the maximum. So the maximum would be 250, 95.
mhm.
Oh no, I picked the 140 because I was thinking is the minimum out of the maximum regret.
Yeah,
So,
that was my thinking as well.
yeah, so the first row you pick correct, like you pick 165, and then the second row you're supposed to pick 140. The third row you pick 250, and out of this maximum regret you pick the minimum one. Is that how I understand?
Sounds excellent. That's a good way to address this question. Yeah. I mean, Katie, you calculated all the regrets, correct? However, to make a decision, we find a maximum value for among each row, then find the minimum among these maximal row maximals.
Okay, so you find the minimum underneath each one, and then you choose Oh gosh.
So Katie, I think the easiest way to do it is you subtract the opportunity cost from each of the numbers. Like, so 250 minus, sorry, I'm pulling up my thing too. So you do like 220 minus 220, 220 minus 85. So you do it for each row. And then from there, you look at the rows first to see the biggest opportunity cost. And then you do the columns to see, which one comes out to be like the low between the highest ones that you get for each row, which one is the lowest. So if you see for single family homes, you got 165 and then 140 for apartments, and then condominiums, you got 250, then you just find the minimum of those max values, if that makes sense.
Yeah. Oh,
So the first row is supposed to be 165,
Yeah.
not 95. If you mark
Excellent.
that one, you will know exactly.
okay. It's this row column thing that gets,
Yeah, that gets kind of confusing.
yeah. Thank you.
No problem. And since your screen is already up, I have a quick
Yeah.
question. Jerry, for part B, do you mind explaining how to get the extreme pessimist? Because it's very confusing, like the wording that that the professor uses, and I just get confused about how to choose the correct one because I didn't get the single family homes. My option that I chose was the I chose single family homes, but I chose the 220.
The second one, the B.
Part B, exactly.
Part B, I choose the apartment.
Oh,
I see.
so
Okay, sure. So for understanding what it means by being an optimist or a pessimist, it's helpful to think in this way. So if I make an act A, whatever this act means, I would hope to get the best result of act A, right?
okay.
So that sounds like a optimist. So if I would prepare for the worst result of my act A, then I look into like the smallest possible return from act A. So we use this rule to interpret what it means by a manager being either optimist or pessimist for building these alternatives. So under each option, if for an optimist, the best result is expected. So for example, when building a single family home, I would find is the best return would come from, then I would hope that situation comes. Then if I make another act by building an apartment, then I would also target at the best result for an optimist. So on the opposite, a pessimist is that for a single family home, we prepare for the worst result if we build any single family homes. And similarly, for a pessimist to build condominiums, he or she would prepare for the worst return out of building condominiums.
Okay.
So
Now I'm
what?
rethinking my answer.
So I'm like trying now. I'm trying to figure out. I think I did the whole thing wrong.
No,
Yeah.
so what I did when I do is like I always remember. So for optimist, it's max, right? So when you pick every single max and then picks max out of max, and then pessimist, which is minimum, max out of minimum. So you pick the minimum and then you pick the max. So I think that one that he was mentioned about the mix max and mix min, it was very helpful to me. I just my step, like I just sharing how I remember it.
Okay.
Oh, thank you. Yeah, That sounds probably easier than what I said.
So for like, sorry, Jerry. So for like part A, when we're looking at the optimist, we look at all three rows, all three options that they provide us. And then as Katie did, that she highlighted the most optimal decisions that we could choose from, then we choose the highest value of those optimal decisions.
Yeah. Mhm.
And then for the pessimist, you would choose the least return for each row and then choose the highest of that number.
Yeah, correct.
Oh, so it'd be 85 apartments for the pessimist.
Yes.
Oh, okay.
Mhm.
Okay.
Yeah.
I'm glad we talked through that because that
Yes.
makes
Thanks for sharing your screen, Katie. It makes it so much
Thank you
easier
for
to
the
like look at
highlighting.
it.
yeah. Once you like talk through it.
Wonderful. I was
if you
curious
want, we
how
can
you
look
did
at-
for D.
I know, hopefully.
This is D is a retrospective review, basically, with what we did in a previous homework for calculating the expected value for a discrete random variable. Here, the variable would be the value, and the probability masses are given as you quoted in the probabilities rule. Wonderful.
So,
I have the same answer.
okay, I was like, so am I supposed to do more calculations?
No,
No,
Oh.
you
Okay.
did a good job.
Oh, good.
the
I put
chart is
the-
very clear.
I know your chart is amazing.
okay.
I may have to like do something similar because it makes it so much easier to read it.
Oh, well, part E was not, that part took me the longest. So that is not a clear chart yet.
I do want to ask you a question though, Kitty. Last
Yeah.
time you made a, you know, the HIV.
The tree
Yeah.
thingy.
What software? How did you make that chart? Like, you know, like looks
Oh,
like
just-
a decision tree.
I just did Excel and I used the borders.
Oh, that's smart. Okay, that's really smart. Because I tried to make decision tree, but it's not working. Like I can't
Yeah.
type the words on top of the line. Yeah, thank you.
Yeah. Because well, if we look, so I can show E if we don't have any questions on D. If that looks like we all figured that one out. Here I'll
Oh,
wow.
nice job.
Oh, good. Oh my God. The so for problem E, that one was weird following along.
Okay, so
From what
would
I
you like to
understand,
share some of your
yeah,
thoughts?
let me
So
share again because I could do a side by side unless someone has a better
I can share, or
oh yeah.
yeah, so what I did is, because they want us to calculate the EVPI, which is the expected value, like in the perfect in the perfect condition, something like that. Like, I'm sorry, I totally forgot EVPI, what it stands for, like a expected value perfect. How did you guys?
No, I think yeah, I'm following.
Yes.
Yeah, so I did the same thing as yours on the 201.5 on the EV, right? And I'm trying to calculate the EVPI, which is I got 133. So I got 201.5 minus 133.
Oh, interesting. Well, do you want to here? I can stop sharing because I'll just what I did is I was trying to follow. I did the basically it's the probability of the declining, the stable, and the growing population. So those three totals.
Mm-hmm.
And I did oh yeah, And then I chose the best one out of those, the
Oh,
172 to minus from the 201. So that's what I did. I don't know if that's what I heard. That's what I was seeing from the videos was right, is that you do the best case for the populations, right? Let me
Mhm.
do best case for
Yep.
each population.
Sounds good.
And then you do the best case for the total population. And then you take the best one minus the best case.
now I'm lost. So I did the same thing as your 201.5, which is
Yeah.
the reverse, right? Reverse the decision tree. And then I'm gonna have to calculate so the EVPI, which is the reverse decision tree, the EV minus that, the one that we just did, the maximize expected value, which is we calculate on the D, which is 133. So that's what we can get with the imperfect information, right? So the one that we calculate the EV, which is the 201.5, which is the one that we can get from the consultant with the perfect information. So we're using that one minus the up one, 133, we got 68.5, which is what we maximum will pay for the consultant to get this result. That's what I understand it.
Here,
Sounds reasonable.
Here, do you want to share?
Oh yeah, I can share my screen.
But
But
well,
I didn't have anything on it actually.
see. The calculation for the expected value of the under perfect information that Katie did was excellent. So
Oh,
you did
good.
a good job here. However, I was just curious how you got the $29,000 value eventually.
Well, two things is one, this says it's the profits in thousands of dollars.
Oh, okay.
So that's why I made sure to put it in thousands down here. And then, because this is the total, this 201, right? This is the best case by individual added up. So that's the total. And then this 29 is the best case
Oh,
total here minus.
I see. You use this. Okay.
Is that?
Well, in this step, you already used the information. Did you realize that? So
Wait, say that again.
Could you show me how you calculate C20?
C20, yes. Oh, I grabbed, because what I did here
11.
is I
Oh.
added these three together.
I see. So, okay, for the, as I said, your steps for calculating the expected value and the perfect information looks great. However, we want to find how much the information is worth, right? That means we also need to subtract this perfect information expected value. I mean, we need to take out from enter the normal situation, the expected value from the expected value of perfect information, right? The latter part should be built not that specifically under stable population, though.
Can you repeat one more time?
Yeah, so when Katie calculated this C20 cell for the expected value without perfect information, right? So we won't be able to know that the population is stable. So that's why it's not appropriate to analyze the value under this scenario only. So what I meant is that on the on the row 11, those calculated values are, let me take a look again. C7, C8, C7, C9. Yeah, these are, I don't think they have particular meanings. But maybe Katie had some other thoughts. So why did you calculate this row 11?
Oh, for some reason, I thought that's what he was trying to explain in his videos. That
Okay.
he with this like reverse math, where you take the 220, the 85, and the 30, and you multiply it by the 0.3, and then you add them all together. But I think I need to watch his videos again.
Yeah, unfortunately, the reverse calculation won't involve the calculation you did on row 11. Because as I said, without perfect information, we won't know where the population grow, right? It could be declining, it could be stable or growing. So assessing the situation only under stable population won't be reasonable. And it doesn't seem that the way you, the row 11 was built was carry any specific meaning. So
Okay,
yeah,
then I will
well,
just get rid of those.
well, then how about Ziyu? Would you like to describe how you found the expected value without perfect information?
So the question D, which is it's already calculate the expected value without the perfect information.
Wonderful, you're a smart person. I like it. So
We're just using that numbers and subtracted by the one that we did, 201.5.
Great thinking. Yeah. So many times in the homework, it doesn't really need extra effort. So we just take advantage of what we did in D. So remember that in D, we need to find the maximum expected value, right? That's exactly how most decision makers usually make their decisions. Find the expected value and find a maximum among different alternatives with different expected values. So we already did this job in part D.
Oh, so it's the best case by individual population by the best case expected value.
Yeah, so in part D, we basically address the question, no matter what the population grow, or actually the population grow just probabilistically to its to the knowledge that we know, what would be the best choice we can make. So we already found the answer to build the maximized to build the alternative, whichever comes with the maximum expected value. So that's what we would do without the perfect information regarding population growth.
Interesting. Okay. I'm going to go back and watch that video again too, to make sure I get it.
It's confusing.
That's why I show up here. It's helpful to talk through it with someone.
Especially, I think, like, we have to really do over and over, and in order to figure out under the 1 hour pressure. And
Oh yeah.
you know, when we take when I take the quiz, if I'm not very 100% familiar with it, it went blank. Like my brain, like I couldn't even figure it out. That's why the 1 hour pressure was like taking place, even open notes.
Agreed. I double check like everything, even if I already like, I'm like, well, that's it. But is it? I should double check.
No, you're good. I never had extra minutes to double check.
Oh, no worries. You all did excellent job. Yeah, I know that exam is somewhat different because it has a time limit. So don't let that disappoint you.
Those Mondays are one of the most stressful hours of my entire, like, it feels like one of the most stressful hours of my entire
Oh
life
my
when
God.
I'm like, oh my God, I have 5 minutes left. Oh my God, I'm not done. So yeah, it's very, very stressful.
Besides
a lot- There's
It
a
also
lot of
sounds like-
screaming that comes out from my mouth, and all words like I normally do not say to my computer that come out from my mouth during that hour.
Well, I'm glad it's the last one was over.
Oh yes.
I
Oh, that
totally agree.
The
Like,
good thing about exam for me is that it'll be over when it's over.
exactly.
Yeah.
you know, besides the first exam, I never submit my answer by myself. It's always automatically submit for
Very true.
Oh yeah. Same. That makes me feel better.
Okay, let's go to the next one.
So for this, I mean, because I'm already sharing, I already have the rights. I took what I thought was the formula he told us to use, the normal inversion, where you take the random number he provides with the what is it, the standard deviation and the mean to give you your units sold, and then you just use your normal profits minus expenses to give you your net profit. I felt like this one might have been too easy, so I thought maybe I did something wrong.
Oh, I did exactly the same with you. Besides, I used the round one. You know, the round one that rounded the units sold. But I don't know. I have to ask Jerry, see if both of them right, or we have to, you know, Jerry.
Mhm.
So I'm just wondering, do we need to round it?
No, you don't have to. It'll be like minimum, very small difference. But you could.
Okay, so I'm not changing my answer, right? I round it. Okay, thank you.
So yeah, Kitty did an excellent job here.
Oh, thank you.
Yay.
Whew.
I know.
The example had more components, and so it was.
Oh, okay.
So that's why I was worried that I was missing something, because I felt like this was a little bit more straightforward.
No need to overthink. Yeah. So what extra thoughts did you have earlier?
Well, there was only a few pieces of information. So I was like, well, this is, but I know like last homework with the like expected payout, like I wasn't thinking, I don't know, like the 100, 200, 300, 400, like that didn't click with me. So that's why I was like, am I missing something?
Oh, I see. Okay. So here, since we need to make a Monte Carlo simulation, and we are given some random numbers, and you did a wonderful job to translate that into units sold. But let's see, since you already, it seems you worked with extra effort. Well, how do you interpret when we take the inverse normal distribution function?
Like, what does the normal inverse mean?
Nope. I mean, here, what's the relationship between the random number and the units sold?
I think it's just telling you randomly on a percentage or from 0 to 1, what's going to be the standard deviation of it from the mean.
I see.
And so this is saying, you know, like it's gonna be 0.51 from the mean.
Okay. Oh, I see. Do you have any thoughts on how the random numbers are distributed?
Oh, they're just, well, I mean, normally in this example, you would use
Ah,
like the random variable, like equal rand with the parentheses, and you could do, you know, 0 to 1.
I see. Yeah,
But
well, you
he
did that
provided
well.
us, he
Okay.
provided us the random numbers because I think he's probably
Excellent.
looking for an easy way to look at and grade the homework.
Yes. So here are some information that you might find helpful. These random numbers, as you said, were generated by using the random number generator. You can do that in Excel just by typing a function starting with equal sign and rand. So by default, all machine or computer random number generators usually use a uniform distribution between 0 and 1. So if we can make some histograms for these random numbers that's given in the problem, and we can find that the histogram of these random numbers for its distribution, and it's between 0 and 1, and it's like a flat line, or we can find bars of a similar heights between 0 and 1. So that means the random numbers generated are always between 0 and 1, and they have equal probability or chances to get a number between all the possible numbers, among all the possible numbers between 0 and 1. And now the step where you used this normal inverse function is to translate a uniformly distributed random number into a normally distributed variable. So that's what it did. So we randomly generated some uniformly distributed number, then we translate that to a normally distributed random number. So that's how we could get the units sold as a normally distributed random number. So to address your question you had earlier, so how what we need to do after we get this randomly generated number and translated that into uniformly distributed units. So the way this question illustrated was an excellent way to understand how to take advantage of such random numbers. Because the units sold follow a normal distribution, so we can find the expected value by simply take the average. That'll be the mean value of the units sold. That will also give us the expected value of net profit after we understand the relationship between units sold and the profit. Okay, I see. I guess the thing you were wondering, you were not sure is that the trials, because we were given 10 random numbers, they're equally weighted. So that's why we no longer need to weight them again with other things.
That sounds good to me.
All right, excellent job. Any questions about problem 2? How about other students?
No, I'm good.
No, thank you. I'm good.
Thank you, everyone.
I'm good.
Wonderful.
Thank you so
Yes,
much.
thank you.
Yeah, thank you, Katie. Thank you, everyone. Bye-bye.
Thank you.
Thank you, Katie, for your work and sharing. And
Yeah,
have a great evening.
You too. Thanks.
too.
Bye.
Bye-bye.
Bye-bye.
Bye.